This is Britt Caswell with another example video. In today's video, I'm covering example 4 from section 5-3 in the SavvasRealize Algebra 2 textbook. The goal of this video is to write the equation of a transformation. So we're given some graphs and we need to write the equation out. Alright, now remember this is the general form of an equation using those transformations, so that's kind of the format I'm going to use. So on this first equation, I'm actually looking at a cubic function, a cube root function, because I have that distinctive S shape. Now what I like to do on these is I like to draw the parent function out just so that you guys can see like what transformations might be happening. Now be aware that on this, Savvas has actually changed some of the scaling on these graphs. So notice that on the x-axis, each box is counting by 2, and on the y-axis, each box is counting for 1. So that's going to cause our graph to look kind of compressed horizontally, which is kind of annoying, but here we go. So when I draw the parent function for this, I actually start with the Orion's belt. So I put a point at 0, 0, then I go 1 unit to the side and 1 unit up, and 1 unit to the side and 1 unit down. And that is my rough sketch of my parent function. So now that that parent function has been drawn in, you can very distinctly see that there's been some kind of stretch. Alright, and the way that I identify that stretch is I compare this right value here. And I'm looking at the distance from my anchor point to the x-axis. Okay? So on my parent function, that anchor point is 1 unit from the axis. However, on my new function, it's 2 units away. So there has been a stretch where that distance has doubled. And so that's my A value. And it works that way for any of these graphs. When I go 1 unit to the right, that A value kind of pops out. Now this function hasn't had anything else happen to it. There haven't been any translations because it hasn't gone left or right or up or down. So I'm not adding or subtracting anything. I just finish it off with the x there. So now let's look at the square root function. So again on this, the x-axis is counting by 2's and the y-axis is counting by 1's. So the square root function, because this was a square because it's half a parabola, right? The square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. So there is our parent function. And it doesn't look like there's been any stretch or compression. This looks like it's about the same swoop. Now if you're nervous about it and want to check your A value, when I go 1 unit to the side, my graph is going up by 1 unit, which is what it should be doing, right? And so that's how you know there's no stretch or compression. So when I go to write my function out, I'm not going to put a number in front of the square root here. Now the function has been moved to the left and it has been moved down. Okay, so we're going to show those by adding and subtracting things both inside the radical and outside. So the first thing is the translation to the left by 5. Alright, so horizontal changes are inside the grouping symbol. And so that left by 5 shows me a minus 5 here, so I'm going to flip that sign and call it a plus 5. And then this graph has also, running out of colors y'all, been shifted down by 4. So I'm going to subtract 4 outside the grouping symbol. Okay, so now let's try doing this one without drawing the parent function. So I know it's a cube root function because of the S shape. Alright, now this has not been shifted to to the left or right, right? So there's not going to be any addition or subtraction in the grouping symbol. However, it was pulled down by 2, so I'll subtract 2 outside the grouping symbol. And then to identify my A value, I'm going to go 1 unit to the right. Notice the scale here now. Each box counts for 1. Thanks, Savvas. So I'm going 1 unit to the right. And you could see when I go 1 unit to the right, I go 1.5 units up. So my A value is 1.5. But there we have it. That is writing the equation of a graph based off of the graph using transformations. Until next time.